Okay, okay, sounds good. Okay. If you guys, I'm not sure, you can check everyone and to the camera, make sure guys behind the screen and listen to me. Please don't play game behind the screen. I sometimes heard some parents say you could maybe play behind the screen, but please be focused. All right. Don't play game. Just only 30 minutes, right? New topic, new things. If you learned, you will learn. If you didn't listen, you have to go back to check the video, learn again, take more times, right? So why not just learn right now, right? Just a suggestion. But if you want to really play game, I really told you, just spend this additional 30 minutes with us and listen and learn something, and you can enjoy your play the rest of your time after class, right? Okay, so right now it's the week 27. We're only 5 weeks left. Totally 32 weeks, including this week is 6 weeks, but there's some graduation ceremony and many things, right? So we try to, and also final quiz, final exam. So take much time. So not much time left. Hopefully you guys can spend this kind of short minutes with us and learn something good things. So since we learn a rational expression, we already learned how to simplify, right? We find an undefined situation, undefine the rational expression, and simplify, we learn times and divide. Right now we move on, plus and minus. That's today's topic, adding and subtraction. Okay, so adding and subtractions. Let's go back to see what you learned before learning rational expression, when you're learning the fractions. Something like say A over B plus C over D. All right, so how you guys do this one? So normally you would do is say, okay, let me give a number example, maybe easier. Something say 3 over 5 plus 4 over 7. All right. So since these kinds of fraction, when you do addition, what do you guys do first step? You try to make the denominator the same, right? How do we make your denominator the same? Both time in this fraction, you times 7, this one times 5, right? So you got to find the least common denominator, right? Least common denominator. So times 7, both times 7, right? You need to do both of them. And numerator and denominator, you do both of them, right? So you at this moment, you can see it's got 35 over 21 and 35 over 20 over 35. And you have the same denominator. And right now, in the same denominator, the denominator part is keep the same. The numerator part do the addition, right? So you got 41 over 35, right? So you can from this kinds of example, you can see when the denominator is the same, their denominator is the same situation. When their denominator is different situation, it's unlike situation. So you needed to find the least common denominator we call LCD. So this rational expression is exactly the same as what we learning before. Like when you do the numbers, only situation right now is they are not numbers anymore. They are polynomials, right? They are polynomials. The numerator, denominator, they are maybe one term, maybe multi-term, right? They are not just numbers, right? So let's see some examples. So this is a typical case. So if you don't understand, just go back and check your fraction. How you do the fraction when you do the plus and minus, when their denominator is the same or they are not, they are different. How you handle this situation? So you can go back to check what are we doing. All right, so let's see some actual examples. That's what I say right now. All right, that's what I say. When you find the fractions, when you see the fractions, if their denominator is the same, right? You keep the same. The top part, the numerator is plus together. Same to the minus case. If their denominator the same, the numerator part is minus by itself, right? Okay, so see some example here quickly. So add these two. So you can see this is one of the rational expression is the rational expression. Their denominator is the same. So we just keep it the same. The top part numerator is 9 plus 3. So you got 12, right? Out of here. So super easy case. So this easy case, right? Like same. Their numerator the same. We keep it is. And the numerator part, denominator the same, keep it the same, keep it itself. And the numerator part, so you can do the addition. And after that, we simplified, right? We learn simplify right now, right? So you can just get it here. All right, same here. Same here. You can see this is one rational expression minus another one, right? So the denominator is keep the same. And numerator part will minus. And you can see the fraction, numerator and the fraction. We do a simplify. So finally got a 1, right? When do a subtraction, again, see this kinds of example, right? So denominator is the same. We just keep it as it is. And right now, what do? We needed to do the minus part, right? So 10x minus 5. So actually in this part, we can do a little bit further. Did you see that? You can see that. So here is minus 8x. So actually this one is changed to like this. Can you guys do some fraction, factor this part? This can be factored into what? 3x minus 5x minus 1. Double check it. 3x squared minus 8x minus 5x. And, oh no, here is plus 1, right? Minus 5, minus 8, and, oh, I'm sorry. Here is plus 5. I'm doing wrong here. Here is plus 5. Because of minus 10x minus 5, right? Should be plus 5, right? So factor begin like this. So it means numerator begin here and denominator is x minus 1. So factor this out and finally left is 3x minus 5, right? See this situation, see this kinds of example, all right? So you can see the denominator is the same. So we keep it as it is, right? What about this part? So you can see here is 4x squared, 15x minus 8x became 7x, right? So here is minus 15, minus both, minus ax minus 15. So you can got this part, right? So you can factor this part. Factor this part sometimes take a little bit challenging. You need to take a little bit longer step. But so you guys maybe see, oh, they are maybe have the same factor here. Let's double check. 4x squared negative positive 12 minus 5. So you got 7, right? So we factor correct. So this can be factored out, right? So finally left over is 4x minus 5. So for the same denominator case, it's much easy because of that the same, the denominator keep it as it is. And after that, we do the further simplification. Simplify the rational expression. All right. So let's go find if the denominator is different or they are not alike. What do we do? Right? What do we do? So first step, we need to find the called least common denominator, just like an earlier example. What are I talking about? Need to find the least common denominator. Least common denominator. I know this is the example here. Okay, so a minus 1. This is 2 factoring, right? This is based on numbers. So how do you find the least common denomination? So here is 2 times 4. Here is 2 times 11. 2 is the common part, right? So least common denomination, the common factor we only take 1, right? 2, 2, we take 1. The rest we need to do both. We need both. So this is their least common denominator. So it means if you want to make their denominator become the same, here need a time 11, right? Here need a time 4. So you can see here 2 times 4 times 11. Here 2 times 11 times 4. They both get this denominator. So you need a time 4 here. I'm sorry, here need a time 11 here. You need a time 4 here. Right? So right now you can get here is 88, or you don't necessarily write 88. And here is over 11 over 88. Here is 12 over 88. Right? So when you do the addition, they became same denominator. So same to the rational expression. See this example. See this big example. This is one rational expression, this second rational expression. Right? So you can see the denominator is different. So we need to do is, what do we need to do? We need to make sure their denominator is the same. So 5x here over 7. Here is 6 over 15x squared. So this part actually can be breaking down 5x times 3x, right? So exactly the same. So you can see this one, if you times 3x, you also got a 15x squared. So least common denominator would be this part, right? 5x times 3x. So you can find it. So you can get the same denominator. You can easily do the calculation. Okay, right. Let's see this one. This example. So this is rational expression, this rational expression. You can see what's going on here. Here is x, here is the x plus 4. So they are totally different, right? So let's common denominator. So x part, so you have to do what? Time x plus 4, right? What about this part? So you need a time x. So in this situation, the denominator is the same. So you can do the addition and multiplication, and do the addition or subtraction. All right. Okay, so let's see. Oh, some more people joining. Let me see who is on the waiting. I'm sorry, I see someone was just joining right now. That's okay. I got it. All right, let's see more complicated case. This one is obviously because of this is numbers, only one term. We will see some more specific case, these kinds of case. Okay, how we do? All right, so let me zoom in a little bit, make you guys can see better. Okay, get better. Okay, so see this situation. All right, so this is rational expression, another rational expression. So this denominator is this t squared minus t minus 6. And this one t squared plus 3t plus 2. What's the LCD? Is this part? Is this part? You can say yes or no in the chat part. If you say yes, right there. If you say no, also right there. Is the LCD is this part or not? Anyone? Can you guys unmute yourself and answer? Anyone? Just make some noise. Yes or no? If you say yes, put your name here. If you say no, put your name here. All right. If you write on the screen, I can see your name. Who write something here? All right. Everyone, please write what's the LCD is equal here or not? Their least common denominator. I need to ask someone ask me. Jalen, is the LCD is this one or not? Is yes or no? Okay, maybe we need to explain a little bit more. I don't see anyone respond to me right now. Actually, no, right? Because what? You can see these kinds of denominator, you can factor into what? T minus 3, t plus 2, correct? This part can be factored here. What about this one? This one can be factored into t plus 1, t plus 2, right? So you can see they actually have a common factor here, right? They are not exactly use this one time this one. That's why make it so complicated, right? So least common factor. So right now you just need this is common factor. Just like right now, what I would say 2 times 11 and 2 times 4. What's their least common denominator? And this one you need time 4. This one you need time 11. So they have least common. Called least common multiply or least common denominator, right? When they are common part, we keep as it is. We didn't change. And they are not a common part, everyone make up. You can see 11. This one have 11, we make up here. This one have 4, we make up here, right? So they have the common factor in this case. T plus 2 is the common factor. We only use one time of them if they are common. T minus 3, they don't have it. So you need 2. This one need 2, t minus 3. And t plus 1, they don't have it here. So you need a t plus 1 here. So right now you have the same denominator, right? So you means you need it at the same time, you need a time here, right? Okay. So keep this in mind. Like these kinds of case, we need a factor first. Find if they have the common denominator, common factor or not. And then we try to find their least common denominator. All right. Okay. So let's go next one. Next example. Next one. Let's see example 8. So these two, they looks different, but actually they only have small difference between them, right? This rational expression and this rational expression. So actually they are just small difference, right? In 2 and here 10. So if you do the addition, how we do that? We can move this part. We can move this negative over here, right? Or move to here, right? So you can just x minus 2, 2 minus 10, right? So here you can get a negative 8 over x minus 2. So in this kinds of case, actually here is, here is easy for you guys to understand. All right, so let's move more complicated kinds of situation. Example. When they do these kinds of rational expression, when they have the different denominators, unlike denominators, how we do the addition and subtraction? Here I list some steps. First step, we need to find the LCD, right? Find the least common denominator of the rational expressions. And then we write the rational expression, make sure they have the same LCD, they have the same denominator. And then we do the addition and subtraction. All right, sounds good. All right, so I will pick some example from here to let's do quick one. I believe this one is not too much challenge for you guys. Let's see this example B. Okay, so here is 10 This rational expression, we try to make the same. So here actually can break it down 5x times 2x, right? It's 5x times 2, all right? So the least common denominator is what? So you need a time, here need a time. I'm sorry, here is time 5x times 5, all right? So 5x is the common, right? So 2x and time 5, one more time, right? So you got a 50x squared, right? So actually means what? Means here need a time 5 times 5. Here time 2x times 2x, right? So you got a 15 plus here is 7 times 2x. Here got 50x squared. So 50x squared, right? So they have the same denominator right now. So you got a 15 come from here, right? Here 14x come from second one. So right now you can do the numerator, do the operation based on these kinds of progress, right? Right. So see the second example. See this one. Everyone understand this one? If you don't understand, just check your parents first, and you don't know, and come back to talk to me and review the video as well when I send out. All right. See second example. All right. So first we need to find the common denominator, right? Least common denominator. So it means this part 3t, we need a time t plus 1, right? So 2 here is t plus 1, right? What about this second part? Times 3t, right? Actually, you can see this one. When you do simplify progress, you can do this part and do this part, right? So you can go backward to this step. So right now you can do the simplify. 3t t plus 1. What are the top part? 2t plus 15t. So got 17t and plus 2. Right. Okay. So the most important is first step. You make sure they have the least common denominator as the denominator. All right. Let's see more example here. You can make you well understanding. All right. So see this one. Okay. So this one actually you can see. So first time is here x can be the first expression can be changed into like this, right? We'll just rewrite it here first. So you can see they have the common factor part here. But this is not least common denominator, right? So this part when you needed to x plus 2. When we time fine. I'm sorry, it should be not x plus 2, it should be x minus 2. Yes, minus 2. So you have the common part, right? X plus 2 is the common part. So x minus 2, you just need to time x minus 2. So they have the same denominator. But don't forget, sometimes people forget here. When you time in the denominator, you need to time numerator as well. At the same time, you need to do this one as well. So when you simplify, you go back this one, right? You didn't change anything because of this one simplify, you go back here, right? Okay, so right now you can see the denominator is the same, right? You can see the denominator is the same. Is it correct? All right, so we just copy down the denominator here first. Okay, all right, so the top part, do the operation 6x minus 3x plus 6, right? So you can got it here became 3x plus 6. we can continue to simplify. Became 3x plus 2, right? Right now, we can even further simplify because they have common factor. Factor out. So you got 3 over x minus 2. That's it. That's it. All right. Anyone have question to this example? If no, I move next one. Example 5. 1 plus this one. How we do that? So 1. So we can change to m plus 1, m plus 1, right? 1. We change it to this one. And right now, the second one we copy. So actually, you easily can get here. The top part, the denominator part is okay, 2m plus 1, right? All right, see additional one, more example here. We get more complicated, all right? But make it simple, think less than logic behind. All right, so see this one. First, we factor this part first, all right? So we can easily to see what's going on. So we take x out, became 2x plus 1, right? The top part with. So here, second one, we factor, again, 3, 2x plus 1, right? Again, 2x. So right now we want to make it have the same denominator. So we just need to times 3 here, right? Because of here, 2 plus 1 is the common factor. Means 3, we add 3 here. Here became x. So you can see this is the same. They both have x. They both have 2x plus 1. They both have 3, right? So here, since bottom, the denominator times 3, the numerator also need to times 3. Since this denominator times x, the numerator also times x. So you can factor them, still go back here, right? This case. Okay, so right now they have the same. So we can, I didn't write this part. We only do the top part, right? So you can got is 2x squared, negative 2x squared plus 9, right? Negative 2x come here, 9 come here. The bottom part is 3x, 2x plus 1. That's it, right? Much easier, much easier. All right, let me find one more example before we end this day. So take your notebook out, write this one. Who do correct and can leaving? Who is not correct? Keep doing at the class, all right? Take your notebook out. Simplify very complex fractions. So this one actually, you guys maybe do this better. Do this before, ever. You can something like this kinds of case. So this is the longest one, right? We consider this is rational expression, okay? So the bottom part. So we will do denominator and numerator part separately, right? Something like this part. So you can do 2. So 2 became 2 over 4, 4 over 2, right? Is it right? Correct? So you will do separately first. Do the denominator and numerator first by itself. Numerator part, you consider a fraction, a rational expression, and denominator part, you also have their own rational expression, right? So you will do like this. I believe you guys can do this one very easy. So how you do that? So it's like 4, you divide this one, so you flip over, right? So this is number part. I believe you guys can do that. So what about when they are doing with the variable piece? So how we do that? We also do the same. We consider this is the biggest one. We consider the biggest one here first, okay? So the top part, we don't changing, right? The bottom part, what are we changing? We make it have the same denominator. It's minus 7x, right? So you can 2 pieces. So right now you can see rational expression divide another rational expression. You can say like this way, right? So now we need to change this divide became what? Became multiply, right? So this part need to flip over, right? So this time, so here we can change into the times. So what do we do? 2, when we do times, it's easy for everyone, right? Like A over B times C over D is equal AC over BD, right? The numerator time together, so you get 21. That's it. That's it, much easier, right? Any questions? Nope. No, I will move on different one. So see the third one case. So first, the same. This is the longest, right? The numerator and denominator. So we consider like this way. So top X first, we didn't change. This one cannot be further simplified, but at the bottom, denominator part can be further simplified. So what we to do? We became, let's then have the same. Let them have the same, right? Right. So what's about to changing into x squared plus 2x minus 1? Is it correct? So here we can divide, actually divide, right? So we change into like this. This divide, right? Divide became times. So need to be flipped over this part. Okay. All right. So what do we do now? So this one cannot be further factored, right? Based on current knowledge, we cannot. But in near future, when you learn a little bit further, you definitely can do that. If you continue to learn math to the Algebra 2, you can do that too. So that's it. All right. So this one change into like here. Okay. I think this is much easier. It's no problem for you guys. If you can do this way, and this one will definitely much easier for you guys. All right, that's all for today. That's all today. I should leave some homework tomorrow, send out tomorrow and video out tomorrow. All right. Any question for this part up to now? Nope. I didn't hear anyone have questions. So, okay, that's all for today. And which everyone have a nice week. See you next week.
Thank you. Bye.
Bye bye.
Thank you.